In this video, I want to talk about surface area and volume of similar figures. So whenever you see surface area and volume in a problem, you might start to think about the different formulas that you know for area and volume, which is great. But if it is involving two similar figures, a lot of times they won't even tell you what type of shape it is. So you can't use any formulas. You have to simply use the relationship between area, volume, and linear units and similar figures. So the most convenient way I have thought about doing this is making a chart. So once again, you're not going to really use a formula for volume or area, you're just going to use the chart. Occasionally, the shapes that they'll give you might be spheres, and if you know those formulas, you can apply them, but it might actually take longer than just solving it using the chart. So I'm going to start with my chart, and the way that I designed the chart is so that the rows progress from linear units to area to volume. The other word for linear, I guess, would be scale. And that's because the scale factor is exclusively linear. So the scale factor is our linear relationship. The area factor is the relationship between the areas, and the volume factor is the relationship between the volumes. Then I have two shapes. The describing words for those shapes are A and B. So what you want to do is you always want to put the shape that you're trying to figure out the value for in the middle. So that's going to be B. And the other shape goes on the bottom. The other way this chart is designed to work is that the middle row divided by the bottom row will always give you the top row. So you want to go ahead and just start filling everything in. So I've got the volume of shape A, which is 400, and the volume of shape B, which is 1350, and the surface area of shape A, which is 280, and I'm asking you for the surface area of shape B, so I'll call that X. So the only thing I don't like about my chart is it almost looks like you could do a proportion. Do not do a proportion. So, not a proportion. It kind of looks like it, but make sure you use this, the fact that the middle divided by the bottom gives you the top. So based on that information, I can solve for my volume factor. 1,350 divided by 400 is 3.375. The reason why I like the factor column is because you can convert between the factor column the same way you would convert between anything that was linear to becoming something that's cubed, or anything linear to becoming something that's squared. So if you think of volume, volume is usually given to us in units cubed. If I wanted to try to convert that into linear units, where it's kind of simply a 1 for my exponent, you're going to cube root. That's how you transfer from something cubed to something linear. A cubed root is going to look like a square root, except it has a 3 here. And you can go ahead and cube root that volume factor, and that's going to give us the scale factor, which ends up being 1.5. Now, if I had asked you for something linear, say a side length or the perimeter of the base or something like that, you would want to continue in this column. Since we need to get to the area column, we're going to convert from linear to area. So in the same way that linear is inches and area is inches squared, all we have to do to go from inches to inches squared is square it. So to go from 1.5 to the area factor, I'm going to do 1.5 squared. And 1.5 squared is 2.25. So now that I have once you have like a full column, you can set everything up. So I can say that the middle column divided by the bottom, row, is going to be equal to 2.25. And so my last step is just to multiply both sides by 280, and I end up getting that X is equal to 2.25 times 280, which is 630. So 630 inches squared is the surface area, of shape B.